What is lithium-ion battery? A lithium-ion battery or Li-ion battery is a type of rechargeable battery in which lithium ion move from the negative electrode to the positive electrode during discharge and back when charging. Type of battery cell. First, cylindrical cell. Second, button cell. Third, prismatic cell. Fourth, pulse cell. Example application. First, smartphone. Second, watch and digital cameras. This case study, we need strategy to perform a material selection for lithium battery.
Introduction. 1. Rechargeable. 2. It has similar structure as lead acid but has semi-permeable membrane. 3. The atomic number equals to 3, which means it has to donate 1 electron to become stable doublet electronic configuration. 4. High energy density. 5. Lightweight. Translation of design requirement for lithium-ion battery. Function is lithium-ion battery. Constraint: rechargeable, high energy density, lightweight, high voltage, can handle many charging and discharging, no memory effect, fast recharge, high voltage, non-toxic, longer shelf life. Objective to maximize the stability of lithium-ion battery, free variable choices of material, choices of process, dimension of battery, cross-section of battery. The material candidate. Screening. Anode material: 1. Graphite. 2. Carbon. 3. Lithium. For cathode material, we have 5. First, lithium cobalt oxide. 2. Lithium manganese oxide. 3. Lithium nickel manganese cobalt oxide. 4. Lithium vanadium oxide. 5. Lithium iron phosphorus oxide. Electrolytes, we have only one, that is pure lithium salt. Ranking. Anode materials: 1. Graphite. 2. Carbon. It has low cost and high availability. 3. Lithium. For cathode material, the first one, lithium cobalt oxide, is high stability and high voltage range. 2. Lithium manganese oxide is a low cost, high thermal and but limited cycling. 3. Lithium nickel manganese cobalt oxide is very expensive and toxic. For lithium vanadium oxide, it has a large capacity, high kinetic energy but limited cycling. 5th, lithium iron phosphorus oxide has limited cycling. For electrolyte, we use pure lithium salt because it has high mobility, can withstand high voltage and temperature, and has a longer shelf life. After the documentation from the technical experts, hence we will use the material of. For anode, we choose carbon because it has low cost and high availability. For cathode, we use lithium cobalt oxide since it has high stability, high voltage range and non-limited cycling. Lastly, electrolytes is a pure lithium salt because of high mobility, withstand high voltage and temperature, and has a longer shelf life. The schematic presentation of lithium-ion working mechanism. The figure shows on how the lithium ions, which consist of positive electrode, negative electrode charges, how they are working. That means the discharging and charging process. At first, discharging. At anode, discharging happens when anode is connected to cathode. So at anode, the lithium electrode will react with carbon to form lithium carbon compound. Then lithium carbon will becomes lithium ion plus electron plus carbon. This releases lithium ion and electron ion. Both of them will move toward cathode. At cathode, at the same time, when the lithium ion and electron move toward the cathode, this lithium ion and electron will react with lithium cobalt oxide to form lithium cobalt oxide. Charging process is happen when the anode and cathode is disconnected. At first, at cathode, the lithium cobalt oxide which is formed now becomes lithium ion and electron plus lithium cobalt oxide. They release the lithium ion and electron. This lithium ion and electron will move toward anode. At anode, the lithium ion react with electron, react with carbon to form lithium carbon, which initially happens on the discharging process at anode. Each time charging and discharging process, it produces a steady 3.7 volt.
Lithium battery manufacturing. Lithium battery manufacturing. First step is electrode coating. Second step is cell assembly. Third step is formation. Fourth step is support services. Next, electrode coating. The anodes and the cathodes in lithium cells are of similar form and are made by similar process on similar or identical equipment. The active electrode materials are coated on both sides of metallic foils which act as the current collectors conducting the current in and out of the cell. The anode material is a form of carbon and the cathode is a lithium metal oxide. Both of these materials are delivered to the factory in the form of black powder, and to the untrained eye they are almost indistinguishable from each other. The second thing is cell assembly. The first stage in the cell assembly process is to build the electrode sub-assembly in which the separator is sandwiched between the anode and the cathode. Let's see, the basic electrode structures are used depending on the type of cell casing to be used. A stack structure for use in prismatic cells. Prismatic cells. Prismatic cells are often used for high capacity battery application to optimize the use of space. This design uses a stack of electrode structure in which the anode and the cathode foils are cut into individual electrode plates which are stacked alternately and kept apart by a separator. Third, formation. Once the cell assembly is complete, the cell must be put through at least one precise control charge and discharge cycle to activate the working materials, transforming them into their usable form. Four, support services. Cleanliness is essential to prevent contaminant, and cells are normally manufactured in clean room conditions with controlled access to the assembly facilities offered via air showers.
Review on the basic lithium-ion battery manufacturing process. Yanin Deng 2017 stated that there are 4 processes involved in the manufacturing of lithium-ion battery, which is electrode preparation, dry room assembly, cell formation, and pack assembly. For electrode preparation, the process involved is mixing and coating, drying and calendaring. For dry room assembly, the process involved is notching, stacking, welding, sealing, filling, and wetting. The both sides of metallic foil are coated with the active electrode material, which acts as current collector conducting in and out the cell. The anode material is a form of carbon and the cathode is a lithium metal oxide. The diagram shows the basic manufacturing process of lithium-ion battery. Based on the 2 articles that has written by Klaus Daniel and Choi Yu Shin, in the electrolyte form process, the electrolytes are formed from paste of active material, powders, binders, solvent, and additive, and are fed to coating machine to be sprayed on current collector foils. In the video, you can see the part that have been marked is a part where the assembly will present on the prismatic cell. Firstly, immerse entirely the battery cell body part, a positive electrode, and a separator in electrolytic bath. The components are then stacked to separator, anode, separator, cathode, and welding of a conducting tap. Wetting process, which performed under pressure of 90 kilopascal to 100 kilopascal. The electrolyte wet the separator, soak in and wet the electrode. This process is performed in a state which the battery cell is taken out of the electrolytic bath and mounted. Next process is activation of the battery. The activated battery may be inserted into pouch then sealed. Last is the packing and vacuum sealing.
Step 1 is mixer. Mixing of the electrode material, which is main share anode is carbon and main share cathode is lithium metal oxide with conductive binding agent. The challenge is no dissolution or breakup of particles, and the target is distribution of constituents with maximum homogeneity. Step 2 is coating. Coating of the substrate which is anode is copper and cathode is aluminium. The challenge is tolerance for coating thickness deviation from 1 to 2 μm. The target is homogeneous coating thickness from 150 to 300 μm. Step 3 is compressing. Drying of the solvent in the drying tunnel in step up to 150 degrees Celsius. Minimization of porosity by means of compression. The challenge is cracking of the material surface and the target is homogeneous, highly precise material Step 4 is drying. Drying of the electrode material and drying chamber with a humidity of approximate 0.5%. The target is reduction of residual humidity. Step 5 is lather or puncture. Firm cutting by means of highly precise cutting or punching or laser tool. Challenge is avoidance of burr formation, fraying of edges of material particles on the surface. Step 6 is assembly. Assembly is taking of cells, integration in housing, contacting of electrode and partial sealing of housing. The challenge in assembly is positioning accuracy of estimation 0.1 mm. The target is taking process with approximate 80 layers per cell at maximum speed. Step 7 is filling. Filling is evacuation, electrolyte filling, sealing and cleaning of the cell in the dry room. The challenge is toxic reaction with air humidity, varying absorptivity, blistering. The target is rapid and homogeneous filling of the cell. Step 8 is formation or aging. Activation by means of charging-discharging routine with gradually increasing voltage storage for 2 to 4 weeks. The challenge is high time and cost expenditures, increased risk of fire. The step 9 is grading. Categorization by means of discharge, resistance and capacitance measuring. The challenge is approximates 5% deviation between grades. The target is identical cell characteristics in battery packs. Step 10 is packaging. Packaging is sorting of cell by grades. The challenge is hazardous substance specification of lithium cells, risk of fire in case of cell damage, relevance of transport costs for plant location decision.
Advantage and disadvantage for manufacturing process control. Tight tolerance and strict process control are essential throughout the manufacturing process. Advantage: elimination of secondary operations such as machining and finishing. Help to reduce the cost. Higher quality product. The more precisely the parts, the more efficiently functionally you can expect. Disadvantage: if it's not done correctly, parts and product will underperform or possibly fail. Require an experienced and skillful operator.